Hello student, good morning. Myself Kirchhoffs DB, Junior College Teacher, Sadhguru Gadge Maharaj College, Karad. In previous lecture, we have seen about simple electrical circuit and Ohm's law applied for such simple electrical circuit for determination of electric current flowing through any branch of that circuit. In this lecture, we have to study the next point. Kirchhoffs laws applicable for electric network. Here, Ohm's law is applicable only for simple circuit, not for complicated circuit. A complicated circuit is nothing but number of circuit elements connected together. For example, number of resistances, sources of EMF are connected together in complicated manner. Such electrical circuit is called as electrical network. Ohm's law is not enough for such complicated circuit for determination of electric current flowing through any branch of such circuit. For that reason, scientist Kirchhoff has given two laws known as Kirchhoffs laws of electric network. Kirchhoff stated two laws for such complicated circuit known as electric network for determination of electric current flowing through any branch of that circuit as well as potential difference across any component of that circuit. First, we define some terms which is applicable for such electrical network. Among them, the first term is junction. Junction is the point in an electric circuit or electric network where two or more conductors join together. Here, this is the figure showing the electrical network having number of resistances. 4 resistances are connected as well as 2 sources of EMF also connected. Such complicated circuit is known as electrical circuit. This is point B in an electrical circuit called as junction point, because this is the point in that network or circuit where 2 or more conductors are joined together. Hence, point B is known as a junction point. Then next, loop. Define what is meant by loop. For that, consider this figure. In this figure, A, B, F, G is considered as a loop. Loop is a closed conducting path, like this. Closed conducting path in electrical network called as a simply loop. In this figure, A, B, F, G, A, B, F, G is a first loop. Second, B, F, D, C, another loop, B, F, D, C, and last A, B, C, D, F, G, A, B, C, D, F, G, A. These are 3 closed paths in an electric network called as loop. Another term known as branch or branches. Any part of network lies between two junctions is called as a branch. Here, point B and point F, these are two junction points. Any part of electric network like this is the part of electric network that lies between two junctions. It's called as a branch. There are three branches within that electric network. This is first branch from B, A, G, F. Second branch from B to F. Third branch B, C, D, F. There are three branches within that electric network. These are some important terms related with the electric network. By considering these terms, we state the Kirchhoffs' first law. Kirchhoffs' first law, also called as junction law, also called as current law. This Kirchhoffs' first law states that statement for Kirchhoffs' first law is the algebraic sum of currents at any junction is always equal to 0 in an electric network. For that, consider a junction point like this, P be any junction point within electric network. These are number of conductors connected with that junction point. This is junction point P. Number of conductors connected to that junction point. Current flowing through that conductors represented like this by the arrow. First, second, third, fourth, fifth, sixth. Arrow indicates direction of current flowing through that conductor. Conductor first, third and fifth, in which current flowing towards the junction, while in conductor 2, 4, 6, current flowing away from the junction. That means some currents flowing towards the junction while some currents flowing away from the junction. According to scientist Kirchhoff, algebraic sum of currents at any junction is equal to 0. While applying this law for that junction, we must know the sign conventions. First, the currents which are flowing towards the junction or currents approaching the junction are considered as positive, while current leaving from the junction are considered as negative. According to that sign convention, the currents I1, I3, I5, I1, I3, I5 are considered as positive, while currents I2, I4, I6 considered as negative. By applying these sign conventions for such junction point in an electric network, according to Kirchhoff's first law, algebraic sum of all these currents like this. Current I1 plus current I3 plus current I5. These are currents flowing towards the junction, always taken as positive, while currents I2, I4, I6 flowing away from the junction treated as negative. So sum of all these currents is always equal to 0 according to statement of Kirchhoffs' first law. That means in general we can write the formula summation of I is equal to 1 to n. I is equal to 0. This is mathematical formula for Kirchhoffs' first law applicable for electric network. Summation of I equal to 1 to n, I equal to 0. From this we conclude that this relation can be written like this: I1 plus I3 plus I5 equal to I2 plus I4 plus I6. This equation shows that total current flowing towards junction exactly equal to total current flowing away from the junction. Means total charge flowing towards the junction exactly equal to total charge flowing away from the junction, because current is nothing but rate of flow of charge per second. From this we conclude that Kirchhoffs' first law is analogous with law of conservation of charge. Then we will study the Kirchhoffs' second law applicable for such complicated circuit called as electric network. Kirchhoffs' second law states that algebraic sum of potential differences, that is product of current and resistance, and electromotive forces, that is EMFs, in a closed loop of an electric network is always equal to 0. This is a mathematical statement for Kirchhoffs' second law. States that algebraic sum of potential differences means product of current and resistance, and electromotive forces, that is EMFs, in a closed loop in an electric circuit is always equal to 0. This is a statement for Kirchhoffs' second law applicable for electric network. While applying that law for any electrical network, we must know about the sign conventions. Used while applying Kirchhoffs' second law for a loop in an electric network. First sign convention: if the direction of tracing the loop is the same as direction of conventional current flow, then the product IR becomes negative. Here A, B, F, G, A is a closed loop. If this arrow indicates the direction of tracing the loop and this arrow indicates direction of current, if both arrows having the same direction of tracing the loop as well as direction of current flow is same, then the product of current and resistance, that is IR, taken as negative. Otherwise, it is positive. This is first sign convention. Second, while tracing the loop, if we traverse from negative terminal of battery to positive terminal of battery, if we traverse from negative terminal of battery to positive terminal of battery, then EMF of cell is taken as positive, otherwise it is negative. We again explain these sign conventions as first sign convention. If the direction of tracing the loop, suppose this is arrow indicates direction of tracing the loop and this arrow indicates direction of flow of current. If both are in the same direction, then product IR is taken as negative, otherwise it is positive. While tracing the loop, if we traverse inside the cell from negative plate to positive plate, then EMF of that cell considered as positive, otherwise it is a negative. By considering this sign convention, apply Kirchhoffs' second law called as voltage law for any closed loop in an electric network. For that, consider this electric network. Consider one closed loop like this: A, B, F, G, A. Suppose this is resistance R1, this is resistance R2, this is resistance R3, and this is another resistance R4, and this is resistance R5. This is first cell, supplies current I1. This is second cell, supplies current I2. When these two currents meets at this point, junction point, addition of current takes place. That current becomes I3, and that I3 equal to I1 plus I2. I3 equal to I1 plus I2. Then consider the closed loop A, B, F, G, A in clockwise direction like this. Start from this point A, B, F, G, A in clockwise sense. Apply Kirchhoffs' second law, that is voltage law, for such closed loop A, B, F, G, A. According to sign convention, we will get one equation. Start from point A to B. There is some resistance R1, current flowing through it I1. Direction of current tracing the loop is same, therefore product I1 R1 is taken as negative. Then from point B to F, resistance R5, current I3, direction of tracing the loop is same as current flow I3, therefore product I3 I5 becomes negative. Then from F to G, resistance R3, current I1, both are in the same direction, therefore product I1 R3 is negative. From G to A, there is cell having EMF E1. We traverse within that cell from negative plate to positive plate. Therefore, EMF of such cell is taken as positive. So, sum of all this, according to Kirchhoffs' second law, voltage law, is equal to 0. This equation can be written like this: E1 equal to I1 R1 plus I3 R5 plus I1 R3 Suppose this is equation number 1. This is equation obtained by applying Kirchhoffs' second law of voltage law for a closed loop A, B, F, G, A. Then consider another closed loop B, F, D, C, B. B, F, D, C, B. In anti-clockwise sense like this. Apply Kirchhoff's second law by considering sign convention for that loop. Start from point B. From B to F, resistance R5, current I3. Direction of tracing the loop is same as direction of current. So product I3 R5 becomes negative. Minus I3 R5. Then from F to D, resistance R4, current I2. Direction of current is same as direction of tracing the loop. Therefore product I2 R5. So I2 R2 becomes negative. Then from D to C, there is cell to traverse within that cell from negative plate to positive plate. Therefore EMF of such cell becomes positive. Last from C to B, resistance R2, current I2 having same direction, product becomes negative. Minus I2 R2 is equal to 0 according to Kirchhoff's second law. This equation can be written like this: E2 equal to minus I3 R5 plus I2 R4 plus I2 R2 equal to 0. This is equation number 2. These are two equations obtained by applying Kirchhoff's second law for the respective loops. Loop A, B, F, G, A, B, F, G, A, and second loop B, F, D, C, B. From this, we conclude that Kirchhoff's second law, that is voltage law, is analogous with law of conservation of energy. Some steps followed while solving the problems using Kirchhoff's laws. These are as follows. Thank you.